This is a homework help video for lesson 5.2. It's page 326. I've picked two problems. I'm going to do number 40, and then in just a minute I'll do number 46. So we're working on compositions of functions, and this first problem, number 40, we're supposed to do f of g of x, and then in just a moment we'll turn it around and do g of f of x composition. So once again, what this means is we're going to take the g function. Remember, we always work from the inside out, so we're going to take the g function and we're going to put it in, we're going to use it as an input for x in the f function. Okay, so the f function will have 4 times x, but we're going to replace x with x cubed plus 2. And then minus 1. And now we just do the distributive property with 4x cubed plus 8, and then bring down the minus 1. So the answer to the f of g of x will be 4x cubed plus 7. And now let's do the other composite, the g of f of x. This time we're going to start with the f function. We're going to use that as our input into the g function. Okay, so in place of x in the g function, I'm going to put 4x minus 1, and that'll be cubed plus 2. Alright, so you have some choices here to cube this binomial. You could write it down 3 times and use FOIL on the first 2 groups and then multiply that result times 4x minus 1 again. Or you could use Pascal's triangle. Remember, the row of the triangle that we would need to raise this binomial to the 3rd power would be the row that has 1, 3, 3, 1. And so I think that's what I'm going to do. Just review the triangle since we haven't seen that in a few days. So to expand this, I'm going to do 1 times, and then I'm going to do 4x raised to the 3rd, and then negative 1 to the 0. Now I'm going to do 3 times 4x squared times negative 1 to the 1st. Now I'm going to do 3 again times 4x to the 1st, negative 1 to the 2nd. And then finally I'm going to do 1 times 4x to the 0 and negative 1 to the 3rd. Alright, and so getting our final expansion, 4 to the 3rd is 64, x to the 3rd, 1 times 1. So that just gives me 64x cubed. This is going to be 16 times 3 times negative 1. So 16 times 3 is 48, times negative 1 is negative 48, x squared. And now I'm going to have 3 times 4, which is 12, times positive 1. So that would be 12. X, and then finally at the last term I'm going to have 1 times negative 1 cubed, and negative 1 cubed is just negative 1. And don't forget, we also had this plus 2 that was already in the function. So I'm just going to tack that onto the end. And now just combining these last 2 constants, I get 64x cubed minus 48x squared plus 12x plus 1. So that is the answer to the g of f of x composite. Okay. Now we're supposed to follow this up with a domain range answer. Well, the domain for all of these problems is going to be all real numbers. We can use any number as an input without any fear of dividing by 0 or getting the square root of a negative number. It's the range that will vary from time to time, but for these cubic graphs, we haven't really talked about cubic graphs much. We will in the future, but let me just give you a rough sketch of what a cubic graph will look like. The parent does something like this. It takes on that kind of shape. And as you can tell, we've already identified the domain is all real numbers, and that's also true with these cubic functions the range will also be all real numbers, and you can tell just by the way the graph is heading, forever up, positive, and then forever down. All of the y-axis numbers will be involved in this graph. So that will also be the range for this. The range will also be all real numbers for number 40. So that's the complete answer for number 40. Now let's take a look at number 46. What we're told to do here is a little bit of what we did last night. We're going to input a squared minus a into this f function first. Okay, so let's do f of a squared minus a. And that just means we're going to replace x with a squared minus a, and then we can go ahead and distribute, and we get 5a squared minus 5a. Okay, and so now this becomes the input for the g function. So g of 5a squared minus 5a. Now we're going to be replacing x with 5a squared minus 5a, and then bring down the plus 1. So distribute -2, -10a squared plus 10a plus 1, and we don't have any like terms to combine, and so that ends up being our final answer. -10a squared plus 10a plus 1. So I hope that helps. A couple of homework problems for you, and I hope that will enable you to do the rest of them successfully. If you have any questions, let me know.